Hello maths fans, and we're back with some Maths Watch help for a Year 9 assignment on algebra, expressions and formulae. Now in this section I'm actually going to go through 3 questions because they're of a similar type, and I may not complete these fully, but you should be able to get to a point where you can complete these. I'm going to start with question 15 from the assignment, and to give you a diagram, hopefully you recognise that is a quadrilateral. Well, it tells us that anyway in the question. Calculate the value of x. Okay, well, you have to use your angle fact knowledge here. What do we know? We know a quadrilateral, the angles add up to 360 degrees. Okay, so what does that mean? Each of these angles all added together is 360 degrees. Got a little symbol here, hopefully you recognise that as 90 degrees. It's a right angle. So if I'm writing this then, I can say 3x, that one there, plus x, plus 90, just tick these off as I'm doing them, plus 2x have to equal 360 degrees. Because that's what those angles are inside a quadrilateral. Remember, that's because that can be split into 2 triangles. I can just quickly show you that. Some triangles from that work that you hopefully have done on interior angles of polygons. Okay, so what have we got? We've got an equation. Now we've done these loads of these, but we've just got to simplify first, and that's the additional step we've got now. Before we try and solve it, we simplify. 3x plus x plus 2x. Those are the like terms we've got there. 3x plus x is 4x, plus 2x is 6x. We've got 6x plus 90 is 360. Don't need the degrees. And now we solve it like we've solved any other equation. What's stopping x being on its own? Well, the 6 and the plus 90. So the first thing I'm going to do is take away 90 from both sides. Am I going to get this in here? We'll see. That gives me 6x on that side, and if I take away 90 I get 270. And what I do is get rid of that 6 now. I have to divide both sides by 6. So that gives me x on this side, and if I divide by 6, I think it's 45 degrees. Does that sound right? Yeah, that sounds right, 45 degrees. Excellent, so that's what x is. Okay. Then it says, when ABCD is drawn to scale, would the lines AD and BC be parallel or not? Now, this is not an easy question, okay? But if you think about lines being parallel or not, you must justify your answer without using a scale drawing, okay? Well, for them to be parallel, we would have to use the facts for parallel lines. So good thing to do, first of all, is to work out what the angles we've actually got here. So we know that that's 45 degrees. 3x would be 3 times 45, which is 135 degrees for that angle there. And 2x would be 90 degrees. Okay. Now, it's saying AD and BC. Now, look, we know that's 90 degrees and that's 90 degrees. Well, look, with this sort of thing, once you know what you're doing with this, you'll be able to answer it. But if you don't, what you have to do is think, okay, what would it look like then? I've got A, first I want to scale, I'll get A to B. I know that's 90 degrees. I know this is 90 degrees. I don't know where D is, but I just know it's there somewhere, okay? Well, these angles, if you look at it, are both 90 degrees, aren't they? Okay? Which means these lines must be parallel because they've both got the same angle to AB. So AD and BC, well, D is going to be somewhere there, C is going to be somewhere there. I'm not really too worried about that at the moment. But AD is parallel to BC. Because DAB and this angle here, DAB, that's angle DAB, and CBA are 90 degrees. Okay. Now that isn't always true. It's only because these are right angles that this works in this case here. Really, what we're saying is, for them to be parallel, this angle here has to be the same as this angle here, which it actually is. But maybe we're confusing things a little bit here. Basically, if you think about it, it's 2 posts in the ground. Okay, if they're both going vertically upwards, because that's 90 degrees. That was a post there, and that's a post there, like on a fence. Okay. That's 90 degrees and that's 90 degrees, they have to be parallel, so they will be parallel. Okay, so that's question 15. Second part a bit tricky. First part hopefully makes sense with an equation. And the reason I'm going on to another question like that is because it also involves having an equation. So the next question I want you to look at is question 22 from the same assignment. And in this case, give information here. The length of a rectangle is 4 times its width. The rectangle has an area of 1,024 centimetres squared. So the area, let's put that in there, is 1,024 centimetres squared. This is the bit that's tricky, isn't it? The length is 4 times its width. Okay, so let's just have a little play around with this. Okay, if I was stuck with this is what I would do. I say, okay, the width. If the width was equal to, I don't know, 3 centimetres, what does that mean the length is? The length would be 12 centimetres. What have you done? You times by 4. Now you might be sitting there, well, how do you know it's 3? Well, I don't know. I don't know at all. So if we don't know something in maths, instead of giving it a number, I'm going to call it X or A or B, whatever you want to call it. It doesn't really matter here. I'm going to call it X just to fit with most of the times that's what we end up using. What we're going to do to the width to get the length, I'm going to times by 4. So I can call that 4x. Okay. So if I put on my diagram now, I've got 4x for the length and I've got x for the width. Okay, so and what they're after is the width. So what they're saying is, can you find the value of x? It's a really, strange way, or not strange way, it's a bit more a problem-solving way of trying to solve a problem with algebra. People say, oh, why do we use algebra? This is the sort of thing, okay, where we start using it in this way. So, area. 1,024 is the area. How else could the area be achieved? It's also area is equal to 4x times x, which hopefully from your simplification work, that's 4x squared. Okay, so what do we do now to find x? Well, we know then that 4x squared and 1,024 must have the same value. So I'm going to write it down. 4x squared equals 1,024. And what have we got again? We've got an equation. Now don't get fazed by that squared. You've dealt with that when we've done things like Pythagoras. We know how to undo that at the end, and that'll become obvious. Okay, the balance lines. Let's go in here. We divide by 4, both sides. So 1,024 divided by 4, that's going to be, what's that, 256, I think? Let me just check. 1024 divided by 4 is 256, yep. So I'm going to divide by 4, get x squared on this side, and 256. Just a little warning here. Some people like to square root straight away. You can't square root until you've got the x squared on its own. Had to get rid of that 4 and make it into a, divide by 4, I've actually got a 1x squared there. Okay, now, you remember back from Pythagoras, if you know that something squared is 256, what's the inverse of x squared? Well, it's square root. So square x squared, I get x, and I'm going to square root 256. Show square rooting. So x is equal to the square root of 256, which is, if I'm not mistaken, it is 16. Okay, and yeah, so hopefully, when you look at it that way, it's not so hard. I think the hardest part there was actually getting the algebra for the length and width. So if it ever says something's 4 times the width, okay, call one x and say, oh, the other one's 4x. If it was 7 times the width, one's going to be x, the other one's going to be 7x. If it's half the width, if the width is half the length, okay, again, you have x for the width, 2x for the length, and so on. Okay, and the clue is in the times there. Look, it says times. Okay, now some questions say the rectangle is 4 meters longer than the width. Well, instead of being x times 4, that would be then x plus 4. Remember, 4 meters longer. So you just got to look in the words for the clues here. Okay, good. Right, so last question I want to look at in this section is question 20. Similar idea here. And what we got here? 5 straight rods. All the measurements are in centimetres. The total length of 5 rods is L. So this plus this plus this plus this plus this must be equal to L. Find out in terms of A. Well, I've just said it, haven't I? So L is equal to A minus 1, tick, plus A, plus tick, A, tick, plus A. Cool, a lot of A's here. Plus A plus 3. Let's just check that again. A minus 1 plus A plus A plus A plus A plus 3. Right, simplification time. L is equal to A plus A plus A plus A plus A. That's 1, 2, 3, 4, 5 A's added together. 5A. And you've got subtract 1, add 3. Minus 1 plus 3, in other words. Minus 1 plus 3, if you have a number line, there's 0, there's minus 1. If I add 3, 1, 2, 3, I get 2 plus 2. Cool. And after that seems quite simple after the last couple, doesn't it? I hope. Okay, I hope that's useful, and I'll see you soon.